Hi, this is Bill Foote, and we're currently in the middle of, oh no, we're beyond the middle now. We're in week 5 of um, an advanced data analytics treatment using system dynamics. This time for inference. Add some inference. And last week we went through these pieces, uh, counting on Laplace, looking at uncertainty and how to measure it. Kind of an interesting approach. We applied this to a pretty standard example. Many of us have used ever since after The Economist, try to practice some supply chain backward bending, trickle down approaches, um, and taxable inference. Probably did that on tax day. And then Daniel Nettle, much more interesting to me, how cultures evolve. We're part of a culture. We have a business culture, part of a larger culture, and it's transcultural. Kind of interesting. Language diversity as a measure of culture, vis-a-vis food insecurity, especially. We used rethinking at slim. Okay, the slim slot of rethinking. That's what the at sign, and R means usually. I don't think it's an R6 object environment, but that's all right. Inference above and beyond. We went through all of that and even asked folks to share their idea of the definition of uncertainty and actually put it into some kind of practice. Um, the week 4 assignment, of course. Okay. Week 5, though, is yet to be set up completely. But it's basically going to be about installing cmdstanr. And I loaded this with several changes and so on as to how to do things. You go through it. It's pretty useful, and it's a bit different than the way that Richard McElreath might have us do things, which if we go there, and if you went to Richard McElreath, spell it right, and you go to his Rethinking GitHub site. See where that takes us. Excel Lab's pretty good, and all of his videos are phenomenal, actually. It's getting into a 3rd edition of things, but this is where you go. So just go rethinking, and he's done quite a few new approaches to this. Okay, and you could begin to look at it. A lot of great reading here. We're doing one of the last things, generalized linear madness, chapter 16. That's where we're actually starting in many ways. We've also covered some other pieces, but if you go on his Robert McElreath here, it's the book package that we're interested in. And here's the package itself, how models are actually set up. The tilde stands for we sample from the density, the probability distribution of the normal, which has a mean and a standard deviation. This is very, very straightforward. But the installation of this full rethinking package is what we could get at in this very short video. Promise it's going to be short. If you go to follow his steps, these are the steps. This is the steps everybody needs to take for anything like this. You got to make sure you have what is called a C++ toolchain, either on your Mac or Chromebooks don't have this. All right, they have it, but you can't get to it very easily, if at all. Mac OS, iOS definitely doesn't have it. We could go to POSIT, POSIT, to get an account there and try to install some of this, but that too won't install unless you sign up for quite a bit more than what they're asking for. And what we want to do is we want to install cmdstanr, which is the R interface to the stan interface to itself, and put in rethinking. And here are the details. First, do this. Second, do this. Third, do this. And we'll do it until it works. Okay, that's kind of where it is. Okay, this is his rethinking package here on GitHub. All of the, you want to see how a package is made, read this one. It's white. It's done properly. It isn't done the way I would do it. I would hack it together. Richard and whoever else he's working with is putting together a nicely developed, from a software point of view, package. But this is the first thing you can do is go here and go to the green button to build the tool chain. And if we go there, I'm guaranteed we'll have so much fun. I'm always on. There were many changes that I had to put in myself. Why this is so here it is. And you can install the source code from here, I believe. Not sure. You can build it. No, that's not how you do it. What we need to go here is here. And this is where all the command stand stuff is. Okay, the shell, licensing, installation. Here's the green link I'm looking for. The user's guide. Pull up the latest, January 23rd. And that's where you start. Okay. There's lots of help. Here, for example, that's where we were. Basically, you want to have an installation, pull it together, and all these pieces will come into it. Okay, so that's command stand, and follow all of the okay. The other part I found, which was useful for me, is this. This is the main site. And you go to installation here. And this basically tells you a lot more information. It helps. Definitely this works. I've been using that quite a bit lately. Very helpful. And the shell interface. And again, you have to unpack things. Okay, you have to try to do that. We're right back to where we started from here. Okay, all the releases, and you're back to the assets. Look, things happen. They crash. Yeah, that was a big problem. Still was crashing, and we got to fix that. Okay. So that's that part of life. Get back to L wreath. Once you get that going, that first part is the hardest part. You then install cmdstanr, and you install rethinking, which allows us to do everything with cmdstanr and rethinking together. This is a thing that we did before, where we're just using just QWOP with rethinking at slim. And of course, all of that works very well. But if you wanted to do something like this with QWOP, for example, copy this into some part of your R Studio, just let me make a new file. I always use Markdown 100%. Figure that part out later. And just start building. You start, this is better than a notebook because you can actually build your whole essay on top of this. And it's the template that we're given. Always get rid of this stuff. No end of trouble. It's very useful, but you got to be careful. There we go. So I have rethinking in as you will have it. And this does the fit. Look at every C of this fit. And we got the 89%. Okay, so keep these numbers in mind, 0 and 84. Very, very straightforward. And now we do, so that was QWOP. Now we're going to do the thing that we're going to be able to do for the next couple of weeks. And this is for Stan Ublom. Look up Stan. Great story. So yeah, we got there. Hamiltonian Monte Carlo. Okay, hit Stan. Let's put that in there. Very handy, that copying button. Okay. Let's run this. Notice Y is going between. It's compiling. Oh my God, it's going to take forever to do that. Why don't we come back to that when it's done? That took like 2-3 minutes right there to get to this point. Everything's working. Still doing a little bit more compilation, finishing up. And then it's going to do something magical. Wait long enough. Right now, it's compiling a C++ program. It's writing a model to C++, which takes little or no time. But then it's going to go through all of the C++ libraries, and there's several, LinPack, IcePack, a lot of others that eigenvalue matrix analysis types of libraries. And yeah, just takes time. Usually taking a lot longer than normal for a lot of things. And get used to this. Data analytics now. My machine is not the fastest machine. Green line over here says it's still running. I have a timer on this, so we'll come back to this. I mean, I actually stepped away for a while and took 0.2 seconds to do something that was compiled here that took 8 minutes. And that's the sort of thing you can expect with new models. Uh, so if we plot the, we can do all sorts of plots, but this will be printing. Let's see. Spell that right. A fit again. Got to be able to spell things properly, of course. There we go. We get exactly the same, nearly the same results as we did before. Much more to this. Um, learn all sorts of things. We can actually read the code. I'm going to find other ways to do this and show you um, the looks like. There we go. That's the same thing all the time. We're building a model. That's the bottom. Mu goes into this. Sigma goes into this. No big deal there. We declare our parameters. We have two in this particular case. We declare our data, simply y, for what we did up here. We got, look at all of this going on. It's awful. I wanted you to see it. And also, there we go. That was the data. Two pieces of data. So I think I could have done this by hand faster. Yes, you could. But I want to show how this thing gets put together. That's the most important aspect of this. Just a couple of more pointers, and we can run off and try to do everything that our Dr. Professor McElreath would have us do. Okay, yeah, you can, instead of denorm, you could use normal. That's the Stan way of talking. Link and sim are Richard's trademark approach. Link, we've been doing our own thing and sim with our own thing. So that's another aspect following his lead on that one. Multi-level models all over the place. And by multi-level model, we often mean, well, these levels certainly, but look, we are taking cuts. This is Berkeley admissions data, and we're looking at it by department, and we have a different relationship with each department. Imagine doing this with ordinary differential equations. Oh my God, I'm not sure I can do that. And I'm not sure I'm ready for that yet. Yeah, I've been doing it and it works, but it's, well, you got to define what you mean by painful in this business because it's all pretty painful, but it's very good stuff. And here's Watanabe Akaike information criteria and leave one out. CV, remember, stands for cross-validation. Where you just put in the log lit for log likelihood equals true here, run the model, and this will take a while to produce, generate results. But this is what happens when you do that. It literally adds another layer in an LPMF, a mass function, probability mass function for the binomial in this particular case. And look at this. Actually, Stan uses, it's a Stan code here. uses the vinculum, the vertical bar, that's conditional. You can also make your own distributions and all sorts of cool things. These are not small things to learn how to do. It takes quite a while and a lot of patience. We're doing pretty deep stuff here. It's the stuff that's inside every GPT. It's been inside AI for years. Missing data imputation, how do you impute that? There's a very, very interesting way of doing that. Okay. And no, I do it a little bit differently. I'm happy to show you how I do it. Islands. So this is a great one, the Oceanic Islands. Um, if you're interested in this, definitely climb the pools and their diffusion. So take the same model, and one of the things I wanted to do in this course was get there, but I don't think we're going to make it because of the time constraint. But the very next thing to do is to run this, but then to run its system dynamics causal model version of this with an ordinary differential equation. I'm sure the lights will dim and the reservoirs will fill and the banks will overflow, but it'll be worth it. Definitely worth it. There's a lot more interesting information inside of that. And social learning, this is very interesting model. Okay, so go through this, and the idea is to use it and play with it. Unless, of course, you know this. You're learning this just to get a vocabulary, basic idea about what things are. The way we all learn this is let's try this out and see why it works or why it doesn't work on my computer or whatever. You learn more and more and more simply by doing that outside of a course. But then we communicate with one another, and all of a sudden things become brighter. One last thing, just want to finish this up with this. Okay, week one, we built our first causal model with Vincent, and we played with it quite a bit. By week two, we're into R, building a more complicated model, and more complication will breed more and more issues when you try to interface all of these with computational resources. We'll call that limit. And the third week is estimation. We use a quadratic approximation technique of Laplace, which we could use with our simulated version of limits to capacity. We could actually do that very interestingly with QUAP. And we're going to end up doing that in week 6 and 7 now and next week, basically, in real time. But we went through a whole beginning of inference here. We had a Bayesian interlude. That's what this template is about. We built a simple predictive model of something that didn't work, obviously, but it's very, very helpful to see why it might or might not have worked. I've already put that inside of a model like this in week 2. That's the Bean model from 2 eastern provinces of the Democratic Republic of the Congo. We learned how to use a scatter plot. Isn't that cool? Very good. And inference. That was the most previous episode, and we built a way to look at the trade-off between volatility, risk, if you will, and uncertainty measured by K. K, the extreme value distribution, generalized Pareto distribution. This is all built off of information entropy, Claude Shannon, and not just a couple of years later, Kullback and Leibler, and these are odd ratios basically. Well, right now we're in the command stand. Our next episode, you're going to look at the simple harmonic model, which is just basically this thing, uh, kind of, and make some more synthetic data, and then we're going to pull some inference off of it. I'm going to actually use Stan for the whole thing. I'm going to attempt to take the SHO model and put it into QUAP and get the same, just compare and contrast, same results. By week 6 and 7, the very end of the course, which is really next week in real time, we'll have our Mootsco and Wolfco folks back. We will finish up with a couple of other escapades in figuring out how to make our model more realistic, not real. All models are unreal, but the representations of kind of like titration, our worldview, et cetera, and all the knowledge and data we have, and we'll have our finale there. And that's where we come, and that's where we're going. I'll leave you with this. It's Bill Foote again, and um, I hope you have a nice day after all this. Anyways, it's going to take a couple of hours to put command stand R up and running. So a lot of room is required on the computer. So do try to get at it. I'm going to try to make a workaround for us to get to see something similar with the quadratic approximation approach that we also learned how to do, which is a real workhorse for us. Absolutely. Because we can still do all of this week 4 inference with it. Pretty important. I'll leave you with that. Thank you very much for your kind attention, and make sure you encourage each other with this. People need encouragement. They need it from you right now, and we need to give it to you as well. Ellie, while it is still today, much to learn. Looking forward to our next episode. Take care and have that good day. All right. Oops. Let me get this thing up and running. There we go.